Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show. Today, bringing you another really fascinating guest involved in science and technology, focused on creating a better tomorrow for humanity. Today, we have the honor of being joined on the show by Professor Abou El-Magd, who is the president of the National Authority for Remote Sensing and Space Sciences in Egypt. They're focused on applied research using Earth observation and geoinformatics and environmental-related issues. He also serves as the counselor for the Minister of Higher Education and Scientific Research for Space Technology and African Affairs, responsible for all related education, science, and technology in Egypt, also with Africa on either a bilateral, multilateral, or African Union-centric agreement. Professor El-Magd is also involved in developing many of the international, regional, and national geographic information system projects in a variety of disciplines. He was consultant for the Center of Environment and Development for the Arab region in Europe for the Arab League, and also spent 5 years of his career in the UK as a GIS Program Coordinator, University of Southampton. He has been selected also as a consultant for various projects related to the United Nations, Food and Agriculture Organization of the UN, World Health Organization, and the United Nations Development Program. Professor El-Magd has also served as General Secretary of the Space Council of Egypt, responsible for setting up policy and strategy of both space and Earth observation applications in Egypt. Represents Egypt as a focal point for the European African Space Initiatives, as well as the Global Monitoring Environment and Security, or GMES. And he has also chaired the high-level National Committee to strategize and develop the National Space Program, which the Egyptian Space Agency currently implements. Has his master's from University of Al-Mansour in Egypt, went on to do a PhD in Civil Engineering and Environment University of Southampton, and we're honored to have him with us. A lot to get into today. Honored to have him. Professor Abou El-Magd, thank you so much for taking the time on the show.
Oh, thank you very much. I really appreciate your introduction. Thank you very much.
Yeah, wonderful having you. A lot of really interesting topics to get into today. I would like to start off, as we typically do, by handing you the floor for a little bit, just to talk a little bit more about your background. You know, I noticed in your master's work, obviously focused on remote sensing and various GIS projects in Egypt, specifically in the area of Lake Manzala on the Nile Delta. Your PhD took you to Kazakhstan to study various aspects of water usage, crop water demand using satellite images and so forth. Talk a little bit about your background and how you got specifically focused in this area to begin with.
Oh, thank you very much. I'm really appreciate to be with you on this show, and you flourished my memory when I go back more than 35 years. When I graduated from Air Science Department at Mansour University, and I have been continuing to do the master degree in environmental air science on Lake Manzala. At that time, in the early 90s, it was remote sensing, just not that common in Egypt or even in the region. I was lucky to start this career in using remote sensing, and I was lucky to work at that time as a first job in my life in the Information and Decision Support Center that belongs directly to the cabinet. So we were advising and give support to the cabinet, to the prime minister about how to use this information technology to support the planning ahead of the sustainable development and resolving critical issues and the challenges that facing the country. Getting into this job with the prime minister and with this knowledge of using the information technology, supported by master's degree studies in remote sensing and GIS, was really overwhelming my knowledge and experience. And afterwards, I successfully got a scholarship from the government of Egypt to pursue my PhD. And I was lucky to be in Southampton University in the Civil and Environmental Engineering department. And it was quite good for me to get into a research study in Kazakhstan, which is another geographical area with different culture, different approaches of irrigation. It was an irrigation scheme like Delta, but it's a bit different from the practices and the implementation of this project. And my supervisor, my professor, which is I appreciate his effort, Professor Trevor Tanton, at that time, gave me the full support. And I did live in Kazakhstan for 3-4 months, not continuous, but in a visit up to 1-2 months each time. And I was migrated into water management, how to use Earth observation information technology to manage the water in a large irrigation scheme like Nile Delta, how to ensure to save water, how to improve the practices of the farmers, how to ensure that the lower tail of the irrigation scheme receive enough water for the yield of the crop. This was another story of my life that polished further knowledge and understanding of how this information technology would help to support even research and applied research to support the government. I was lucky to develop a very good system at that time and deliver to the irrigation authority in Kazakhstan. And it was part of the project which was funded from I think NATO at that time. I haven't got involved in the administrative process of the Professor Tanton, but at least one of the deliverables, we have to deliver something like training and capacity development to the local irrigation authority in Kazakhstan. So I believe this kind of background helped me a lot to give me a very strong, solid ground in my research and career. Lucky to be at that time to get a job offer from Gifford in UK and continue to work for a few years. Different dimensions of environmental engineering and how to integrate environment with engineering construction projects like bridges, like facilities, compounds, all this kind of environmental impact assessment and environmental integration. So I believe my career was just started when I finished my PhD to get into real practices of my knowledge and the information obtained from master's and PhD.
Excellent. Excellent. And before we get into several of the projects that you've been involved in or have going on now, I'd love to do an overview of the organization that you head, as I mentioned, the National Authority for Remote Sensing and Space Science. This goes back, as I was reading, to actually an earlier organization known as the Egyptian Remote Sensing Center that was established in the early 1970s. multiple satellites, EgyptSat 1, 2, and EgyptSat A. I think you're in Cairo, but there's also a receiving station down the Nile in Aswan. Introduce us to the organization and just a little bit of its history and its primary responsibilities per the Egyptian scientific research and technology structure.
Yes, the National Authority for Remote Sensing and Space Sciences is the governmental research institute that is dedicated and mandated for the space technology and Earth observation applications and research, pure research, and applied research to serve the community and the government. It's early started as a center, a small center from a fund coming from United States in early 1970, 71, something like this. And they started from that time, 1970s into 1994 as a small center with building practices and building human resources. And from 1991, it becomes a governmental institute, and then upgraded in 1994 to be the only governmental research institute that equal to the university in research, responsible about space technology and remote sensing. And it was the cradle. This was the cradle of the Egyptian Space Agency. All the space program is being hosted by the National Authority for Remote Sensing, and we built our first Earth observation satellite, EgyptSat 1, in partnership with Ukraine at that time, and they've been launched and successfully built our human capacity up to 66 engineered in different subsystems of satellite. And we did operate the satellite for the lifetime of the satellite, and we obtained huge amount of satellite data that served the community. The national authority continued to implement its role in the government to do application of Earth observation data from different resolution, from different satellites, from different spectrum, to support the national development plans in different dimensions, in geology and mineral resources, in environment, in water resources management, and groundwater management, in coastal and marine, and urban planning, and infrastructure planning, and disaster risk reduction and management of flooding, land subsidence, earthquakes, and the post-earthquakes problems, and how to rehabilitate. All this kind of support it provides based on the data. So once you have a real good piece of data and information and knowledge, you'll be able to provide the decision maker with the right support of decision on time. So this is what we are really do in the time being. And as a president of the this institute in the last 3 years, we do support the government in agriculture and the crop, national crop, how to ensure that the real amount of hectares being strategic crops like corn, like maize, like cotton, rice, all these strategic crops, how to ensure that the government has the exact amount of area, the predicted yield. And we do a model for prediction of the yield that support the planning for the gaps, how to fill in the gaps of the import-export, what we need for to fill in these gaps. All new export crops that require to be promoted, like palm dates, for example, if we are going to we have a large amount of palm dates, how to increase the efficiency of export, where is the orange fruits, all this kind of information on a national level. And this is the key, how to provide the information in the whole territory of Egypt. This is quite important for the government to understand what we have where. And if you are planning, for example, to export a specific crop. So, and this has been implemented all the territory. So what is the newly available for export and what next? And to put in like a pipeline of all this information, we are helping the government using real data to provide the precise information that allow for the decision makers. I think this is one of the key roles that the Institute is doing, together with the establishing the knowledge and technology itself as a research institute in space, how to develop your own capacity for specific subsystem of the satellite component itself, how to ensure that you have a people and engineers that are capable to design a mission analysis of EBS, for example, the power system of a satellite, or the onboard computer, or this. Moreover, we extend this knowledge to training to the universities, graduates and university students, to get a role that this is our commitment to the new generation of getting them up to speed of the knowledge and information. I think it's a wide spectrum of roles, but we are trying to achieve as much as possible, particularly for supporting the government and their decisions about the sustainable development.
And a very interesting collaboration, and I'd love you to talk about this a little bit. And you published a really interesting paper. This is in 2009 at the International Conference on Recent Advances in Space Technologies. It was entitled Deployment of Real-Time Satellite Remote Sensing Infrastructure to Support Disaster Mitigation. And this is a very interesting collaboration between Egypt, to Cairo University, Azhar University, and the meteorology departments, NATO, and then Turkey as well, and with sort of a broad purview to look at all sorts of biogenic and anthropogenic disaster. You mentioned earthquakes before, epidemics, epizootic situations are mentioned in this paper. Talk a little bit this collaboration, because until I was reading about you, I didn't know it existed, but it's quite interesting, and again, a very interesting sort of multi-party collaboration, and then we'll get into some of the discrete projects after that.
Yeah, I think you are right. But if you go back to 2009, at that time, and still up to today, space is a costly technology. It does need a partnership and a collaboration to ensure that success stories will happen. No country will be alone, like our country as a developing country would be able to manage all the space technology alone. So similar to other countries, it's a collaboration, and partnership is one of the key issues for space. And at that time, we were getting into a research how this partnership between Egypt, different academic and research institute, Cairo and Al-Azhar as academic, and NARSS as research, with Turkey and United States, to make a partnership of a climatic data that ensure for the aerosols and the air pollution quality. It's like a network of kind of antennas that receives the data for anthropogenic pollution. It did work for a few years, and it was very successful for the academic research and students to learn how the data could be delivered into such a network, and how to look on a regional level for the migration of smoke, for example, or dust, for example, and what is supporting other pollen grains or some epidemic diseases. So this partnership and the collaboration opens the door for infrastructure sharing, knowledge sharing, research sharing, challenge sharing. So it opens the door for different spectrum of sharing the knowledge and information and infrastructure, and allow to plan ahead for what next, what we could do together for the next to improve this network, to increase the capacity of the infrastructure, to innovate on other applications that help the region. I think this was the key of this exercise at that time. But we continued partnership and cooperation with Germany, with China, with Japan. So I think without getting into a partnership and the cooperation, we would be facing severe challenges. This is why I think partnership and cooperation in this area of space is quite important and necessary.
Excellent. Excellent. So yeah, so with that, let's talk about some of the Egypt specific programs that you've accomplished and published on, because each one's equally interesting and again, it fits into the mission of the organization. I'd love to start. This was June 2012 in Remote Sensing of the Environment. You publish retrieving sand dune movements using subpixel correlation of multi-temporal optical remote sensing imagery. Clearly, as you were mentioning just before, the way the dunes move and the winds blow the sand, this Aeolian effect, obviously significantly important for mega projects, for vegetation, for your predictions, per agriculture. But you were also interviewed in another article recently about, we don't think of the health issues associated with how those dunes move and where the sand goes. You talk about asthma and chronic obstructive pulmonary diseases and respiratory tract infections and everything that comes along with when that Aeolian process goes the wrong way. Take us a little into that, because clearly how the dunes move and where the sand goes in your corner of the world is extremely important. So spend a little time on that one, if you would.
Yeah, I think one of the characteristics of our area is an arid region, which is Saharan, and this Saharan make a sand movement and sand dune migration in two different ways. One of the dust storms, which has a specific time and pathway each year in the season. And I think this sandstorms coming from the Saharan and migrate in specific days according to specific environment in a pathway that come in two ways. One, South Egypt, go up to Red Sea, Saudi Arabia, and go to Turkey up to Europe. And the other one is coming from up north from the Delta down into Cyprus, South Turkey, and go to Italy and something. So this is based on the season and the wind and other supporting environmental issues that put the sandstorms in a movement. Unfortunately, sandstorms will initially create less visibility, which create a problem with the highways and driving to the people, or the high speed of wind create a problem as demolish the infrastructures like advertisement platforms and something like this. But the more critical issue is the 2.5 micrometer and 10 micrometer dust, which goes into the atmosphere and create a problem on the health of the elderly people and children, particularly who are suffering from asthma. And this we are trying to provide a connection with the health. How many kind of people, elderly people or children being infected at that specific time of the season during the pathway and migration of that storm. I think this is one of the critical issues that we try to use, particularly it's repeatable. It happens every year, twice a year in spring and autumn. So how can we study and how to make like disaster management, how to make an alarm to the people via SMS or via any kind of communication platform that at least for this particular time of the day, that please people who are suffering from this kind of diseases, please don't go to the streets, or at least minimize exposure to such kind of dust and something. The other side of the coin is in the low-level migration of this sand, it invades the agricultural land and create a problem with the dunes migration to the agricultural land, and even on the highways. And I have seen highways in the desert that is being covered with sand because of the migration. The article or the thinking behind this, how to use Earth observation data to look at the source. To stop this kind of you have to stop the source, because if the sand comes from this point, definitely it will move due to the natural environmental parameters. So we used this optical data as a sub-pixel accuracy to look at where is the source and the corridors of the movements that could make an easy planning for a new alternative route away from this kind of sand migration. And advice to the government to use kind of biological solutions to put it in the source, to make some rooted plantations that fix this kind of source of sandy dune. So it was like applied project published as a research paper, but it was an applied project in cooperation with other authorities to solve this problem, because the consequences of losses, of life losses, or the car losses or agriculture losses from this sandy dune is huge. So how to, and we cannot, stop the nature and the earth nature from doing what's supposed to do according to the environment. So we have to, work and adapt and mitigate in a way or other to minimize such disaster. So this one of the critical applied disaster projects we have done, and we repeated a lot of places in Egypt, in each geographical location based on its characteristics and what really over there.
Mm-hmm. And while we're on the topic of health and sort of trying to stop nature or at least prevent damage, another paper that stood out as really interesting of yours was this one that this was September of 2024, actually, this program that you did on dengue and the mosquitoes. This was in collaboration with the Research Institute of Medical Entomology in Egypt, and a really interesting two parts. So they sort of are on the ground looking, collecting larvae, looking at sort of things from the micro level and specific houses and so forth. You were obviously in the sky looking down at vegetation cover, drainage situations, different surface temperature changes and so forth. An interesting sort of two-way, program to, again, we can't stop the mosquitoes. And this was down at the bottom of the Sinai Peninsula on the Red Sea. I don't normally think of dengue in Egypt, but take us into this one and how this project was brought to you, because it's another very elegant example of how you're using these technologies for human health and benefit.
Yeah, you are right. I think what we have looked at in this project, how to use Earth observation data to look at the environmental parameters that support and accommodate the mosquitoes to be flourished and increased in numbers, particularly the one vector born as a disease. So because not all the mosquito species are carrying this disease. So we have to go into the local sampling and the lab analysis to understand what kind of mosquito species that is carrier for the disease, and look from the Earth observation what the environmental parameter that help this species to grow up and increase in numbers and make a problem to the humanities. Definitely the water bonds or the soil moisture, the vegetation, the heat, the population density, and the kind of even lifestyle of the population at some cases make acceleration to such mosquitoes to increase. So it was just an integration, how to provide a planning for, please, this is like a red alarm, please, this area is kind of problematic. If we leave it in this way, probably in the next 5 years, it might create a problem for this particular disease, for this particular vector-borne disease from mosquitoes. And I think I was successfully made this kind of project, particularly for malaria in Yemen. I was supervising a World Health Organization staff for doing a malaria for the Yemen before all this kind of crisis. And I done it in Sudan because Sudan was not yet declared as free of malaria with WHO. So it was kind of building experience and the knowledge of this kind of information technology Earth observations that could help and support in the health sector of this particular area. So I think we are trying to alarm because Egypt is declared as a free of malaria, but we still yet we're trying to ensure that we continue our cautions that ensure that this declaration is free and the continue to free, was alarming about any hotspots that might have any cases in the future.
It's again, that's a we're not going to stop the mosquitoes, but again, this is a
We
very
cannot, no.
yeah, a very elegant application again, and one we don't normally think of, but one that we maybe that we do think a little bit more. Again, thinking from perspective of Egypt. Obviously, you're in a very hot area of the world, and this topic of heat islands that you've published on. We just actually a couple of months ago, we had a guest. They're here in the U.S. and they were doing research in Phoenix, Arizona, on the heat island issues there. They're originally from Tehran, obviously another real hot spot, and looking at the issues, not just obviously Phoenix, Arizona is not a lot of agriculture out there, but they affect our health, our agriculture. Elderly patients, much more to an extent, what we breathe, how we feel. You've written on not just studying the urban heat island effect in, say, a city like Cairo, but you've also published on, studying the potential sinks of greenhouse gases and how we could, in changes in, how we plan our cities and plan, future projects, we can, limit the effect of some of this. And I would just, love to, again, hear your perspective on this particular phenomenon, because clearly we're not going to turn down the sun, but we have to come up with innovative ways to plan our future, which is more and more in the cities. Take us into that realm, if you would.
Again, it's how to function the Earth observation data, and the satellite data sensors are different and is dedicated each sensor to a specific application. And one of the key issue is the aerosol and the atmosphere, and how to look at the heat or the temperature in the atmosphere, and sinkholes of carbon emission. I think the thermal infrared of the sensor and camera of the satellite allow us to look at the heat. And if you make it on a daily basis or on a regular intervals, you would be able to look at the changing of the altitude and magnitude of the temperature. And if you align this kind with the human activities on Earth, you might create something, a relationship between why this particular area is a common of high 2-3 degrees as islands. So I think this was a long time monitoring of a specific area, particularly in Cairo, because Cairo is a very densely populated city, up to 24 million inhabitants, with different clusters of industry and other traffic and other well-established urban area with green balance with urban and green. So how to compare all these sectorial of this city into the atmosphere, and where is the areas with high temperature in the atmosphere. I think this research was focusing on this particular heat islands in Cairo, and found some industrial areas that the ceiling are aluminum, the ceiling are concrete, the ceiling are supportive of reflection of sunlight that create extra heat, with some specific island of heat in comparable to other regions. All this kind of information coming from the satellite, when we supported by the terrestrial stations that measure on regular daytime of this kind of temperature, and even carbon dioxide, carbon monoxide, we try to link with other traffics, with population, with the kind. So I believe, again, this is the value added of Earth observation, a value added of satellite data that give you a full picture of Cairo, for example, on a daily basis for 1 or 2 years, to let us know and understand why this particular zone is high temperature, is this particular comparable to others. So again, we believe that space technology and satellite data would provide a support and information to the government or the stakeholders in different dimensions, even in the atmosphere and the heat islands, and even in the carbon monoxide, dioxide sinkholes.
Mm-hmm, mm-hmm. And you know, continuing on that theme of value added now, and sort of moving from obviously done a tremendous work on early warning and mitigation of these major potential disasters. Let's talk about a couple of these other value added projects, because they're equally fascinating, and one that obviously stood out to me right away in your publications was this one from 2014 April in the Arabian Journal of Geosciences, entitled "The Application of Remote Sensing for Gold Exploration in the Forkir area in the Central Eastern Desert of Egypt." And here, you know, you talk about that the desert is quite full of very important mineral resources, and again, using the technologies, specifically the thermal emission, reflection radiometer, able to map the lithology of the area, and identify not just gold, but various other important mineral resources. Again, this is fascinating. I didn't know you could do this. Just looking at patterns in the geologic structures, but say a couple words about this, and did you find any sort of undiscovered gold mines in the process?
I think this is, again, like you just said, about the value added of the satellite data, Earth observation data. And it was a part of PhD. One of my students in PhD is interested and experienced in mineralogy and mineral, and he already working in a company that is focused on exploration of gold. And the theory of gold, how the gold is created and get it into the mountains, there is a philosophy behind it, how it comes through thermal solution which come to alteration to the minerals composition of the rocks, and then concentrate along the cracks and fractures of the geology, and it moves up. So you wouldn't be able to find a 2 kilogram massive gold somewhere, but you wouldn't, but by grams and in the mineral composition also. So the how to use this kind of satellite data to give you the preliminary idea of exploration of gold. So if we look to the mining and where they found this kind of gold in a specific rock type, they try to find this rock type first, and then the lithology of these rocks, and then the fractures. That's supposed to be a very good environment for migration of the sediment solution, and then get into from the satellite data this exact zones that integrate between fracture zones, the specific rock type that could be hosted by gold, the other supporting information from geology. And if you picked up all this information from satellite data and compare it with existing real mining area on Earth that produce gold, so you could integrate both to give an idea to the exploration people that please explore in this area, you might find a gold. And when you improve the algorithm and improve the model, you found the precision of the information you provide to the exploration companies. And I think this happened with different companies in the last few years. And the successful stories that when we advise them to make exploration in this area, they found a gold in this area because of the inputs of the data was high accurate. So the outcomes is reasonably accurate. So they support also the surface exploration of the gold by some in situ measurements. We take some geophysical instruments and other supporting tools to go on site for this particular area for exploration, and we make further measurements, further information obtaining, and then integrate with the satellite data. So I think it's again value of how to integrate multiple sources of information to give you a solution to a specific problem. And we are repeating this now, not just for gold, for iron, for example, for graphite as a source of power, of energy. Other kind of mineral, specific mineral, tantalum. We are working on tantalum now for using Earth observation. So again, it's the value of the satellite data and the value of AI algorithms that you develop that allow you to take all the information from the satellite data with other ancillary data to give you some answers to specific questions.
And Professor, we've been spending now all our time on the land, and I just have to ask because I love seafood, and the other paper that really intrigued me on sort of this value added front was your use of Earth observation for detecting the appropriate fishing zones of the Sardinella species. This was in April 2022 in the journal Fisheries. Say a couple words. I love to eat fish. I hate fishing. I never catch anything, but clearly, if you could get the fisheries and the marine industry in the right spot in the Mediterranean, they catch more fish, and that's important for the economy. Say a few words about that too, if you would.
Yeah, me too. I like fishing. I like eating fishes, but I never been successfully catch fish. So I did try a couple of times, but I was not that man who is good in catching fish. Actually, this is a regional project. This was part of GMES in Africa, which is a global monitoring for environment and security as an initiative from Europe to Africa. And I was part of this initiative, and we were doing this particular coastal and marine project on northern African countries Egypt, Tunisia, Morocco, and Mauritania together in this project. And we were getting how to support the local fishermen for this particular fishing zones of Sardinella, which is good for protein and one of the key fish species for Mediterranean, even in Mauritania as well, Atlantic Ocean. And we got the statistics that a huge amount of this is supporting the local economy for the local market and even for export as well. And most of the people who are catching fishes are the small fishers, not the big boats and the big fishermen. So how to support these people with the local NGOs and other authorities to give them some information about when and where they go, because it's not available for the whole year. It's some patchy areas and some other weather information that might be disable these people to go into fishing. So I'm trying to give them awareness session, give them support, send them SMS on mobile phone, because it's not a smartphone they have. They have only basic phones that you could send them just SMS. One means that you will be able to go to fish. Two, it's risky a little bit. Three, no. So this kind of knowledge sharing and talking together to provide them with support. But the remote sensing data was supportive to get into a daily data for the Mediterranean and Atlantic Ocean with the statistical data obtained from the local authority, with the environmental parameters from the biologist and oceanographer that give what is the favorable conditions for Sardinella to grow and to move in a group, batch groups. So temperature, transparency, salinity, all this kind of information, get it into the data to get a geographical map on a monthly or daily when this could be helpful to go and fish. It was initially how to convert the data and research and satellite data into usable information to the local farmers who doesn't understand anything about maps, about satellite, about something. That if you would like to go to fish, go to this area on these dates. Please don't go on these dates because the weather is not that good. So all this kind of information were kind of a project. It was 3 years project and extended, I think, 1 year. And we made a lot of integration with the local farmers in Egypt, in Tunisia, in Morocco, and Mauritania. And all these sessions, we were getting into direct contact with the fishermen and try to give them the helpful information and supportive information.
Excellent. Professor, one final thing I want to ask about, and we've talked about many topics that obviously fit into your expertise at the National Center, and one of the we're talking Egypt, clearly a major source of our world's archaeological sites, obviously a great civilization of antiquity. I don't know much about exploration of archaeological sites and things of that nature, but clearly if you're capable of finding gold mines and things like that, how much of your organization is dedicated or is allowed to be dedicated to discovery of new archaeological sites? Because clearly Egypt, aside from being the source of the existing sites that it is, I mean, I forget what % of Egypt is sort of covered by sand and desert, and just your thoughts on the potential of the tools and the capabilities at an organization like the National Authority for further exploration in that domain. And is it even allowed? Is that something you're allowed to do?
Yeah, it's allowed. I think the archaeological Egypt is one of the largest countries with the archaeological heritage and different eras of archaeology, from pharaohs to Christian to Jew to Muslims, Byzantine, all this kind of archaeological sites we have. But there is two dimensions of the archaeology in general. One is the monitoring the existing archaeological sites from damage from environmental related parameters.
Mm-hmm.
And one from exploration to the buried archaeological sites underneath the soil and underneath the earth that is buried underneath, or it reduce the risk of this archaeological site from natural hazard like flooding or saltwater intrusion or something. So these three dimensions we are actively involved, but in a case by case, on a specific project by specific request for each one. The exploration of the buried archaeological sites, Earth observation satellite data give little amount of information, but we need and lean on geophysical instruments on Earth that go with the specific devices to measure electric conductivity, for example, or other measurements of geophysical data that support to be integrated with others to give us a conclusion about the exploration, like ground penetrated radar. There is a radar satellite, but the radar satellite penetrates the Earth is a limited thickness. But if we get into a ground penetrated radar, is a device that put it on Earth and penetrate deeper. Penetrate deeper with the analysis, give you a solution to interpretation of what existing underneath the soil. So if it's caves, if it's pathways, if it's concrete, if it's a pipe, so all these GBR is coming. So the satellite data, radar satellite data, wouldn't give you much information, but give you understanding of a wider area, and then go to this wider area or specific area with the GBR, ground penetrated radar device, as a geophysical data, and then integrate together to support the exploration of the heritage that is buried underneath the earth. But the management of saltwater intrusion or coastal flooding or flooding, flash flooding or land subsidence, we also support the antiquity authority for this particular information. So we have a role, but it's not that much because it's project-based and specific request for a specific problem or solution for a specific problem.
Got it. Got it. No, I thought I'd ask just because it's it's quite interesting and
yeah, it is interesting.
Again, be another possible application, but no, it's extremely impressive dossier. I just again, as I was going through your papers, each one equally interesting to the next. What should we be on the lookout for in terms of the National Authority for Remote Sensing and Space Sciences as we get further into 2025? And then I know that you get out to a lot of the space conferences. I think you were at New Space Africa last year. What else is coming up that we can follow you, watch you, maybe run into you at some point at some of these initiatives? And then anything else that's public facing that I missed that you want to mention, please, while we have you today.
Personally, I was a member of the Space Working Group in Africa that developed the African Space Policy and African Space Strategy. And it was the first time that Africa has a consolidated space policy and space strategies that has been adopted by the head of states. And personally, also, I was a man who is responsible about building our file as Egypt to host the African Space Agency. And we successfully hosted the African Space Agency with a specific commitment from the government of Egypt to make a premises for this agency, and it's already there and being started to be kicked off. And I think hosting Egypt to host this African Space Agency as a umbrella of the space technology in Africa would create a very good opportunity for Africa and Egypt to make a major role for space and Earth observation in Africa and in the region. So I believe this Space in Africa is one of the good gathering conference that's been carried out and organized in a couple of African countries. In Cote d'Ivoire is the first version. Second version was in no, not Zimbabwe. It was in Western country. I have been there. I don't remember the name of the country, but this is the third version of the space in Africa. So kind of this kind of conferences and gather all the international community of space and African expertise would create like environment and for partnership, cooperation, and making Africa up to speed in space technology. I think the position of Egypt hosting the African Space Agency, communication and relation made in the world between Europe, United States, and Africa would help in this kind of gathering and making this ecosystem of space and Earth observation in Africa and the Arab region to be in a healthy way to support these countries. I think also the support that we receive from the government for space science and technology and innovation, because space touch base for a lot of other innovation areas, artificial intelligence, engineering,
Sure.
science, it's all industry, all this kind support is the whole ecosystem of science, technology, and innovation. So I believe the government gives this support to STI in Egypt, and to extend this into our in Africa would also help, because we are member of the African Union Commission, and there is a lot of committees and strategies that in Africa that we are part of. Once we share all this kind of STI with Africa and Europe, we gain and gain knowledge and gain experience, and then share this with others. So I believe this also is very helpful and supportive. Finally, I think Egypt, as one of the big countries in Africa, is also try to make a role of a country that would provide help and fund support to other in Africa, and just to leverage the whole capacity of Africa via training, via sharing workshops, all this kind of stuff. So I believe this is very good for the time being, and I think 2025 will be very overwhelmed with events and activities in Egypt for space and Earth observation.
Excellent. Excellent. Well, I wish you and your team the best with all of this as you continue to grow and to create these interesting, innovative projects to inspire the next generation in Egypt in terms of getting involved in these initiatives. But very impressive work. Again, for everybody that is going to be listening to this episode of our show across the podcast networks, or who will be watching on the YouTube channel, again, you've been spending time with Professor Dr. Islam Abou El-Magd, President, National Authority for Remote Sensing and Space Sciences of Egypt, also counselor for the Minister of Higher Education and Scientific Research for Space Technology and African Affairs. Professor, again, I want to thank you so much for taking the time out of your schedule to come talk to us for a little while, to give us the history of what's going on. I thank you for everything you do to advance science and technology. And as we like to say on our show, thanks for helping to create a better tomorrow through inspiring the next generation and developing these technologies. Really, really incredible story, and I look forward to continuing to follow the progress.
Thank you very much, Pastor, for this opportunity for this show, and looking forward to see it.
We'll get it live for you real soon.
Sure.
Great having you.